Okay, this is part 7. I wasn't going to do a video, but just in case, I figured if you have any questions or if you happen to catch it, because I'm definitely not putting it a little bit late. So let's start. Find the GCF 24 and 50. Hopefully you still remember how to do this. And if my pen works. So the GCF, one way you can do this is, hopefully you remember the ladder method. And we can think of a number that goes into 24 and 50. 2 goes in 24 12 times. 2 goes into 50 25 times. Is there another number that goes into 12 and 25? If not, we're done. The GCF, remember, is the number on this side. So GCF is 2. Okay. The biggest number that can go into 24 and 50 is 2. LCM is a little bit different, just a little bit. We can think of 3 goes into 15 5 times, 3 goes into 18 6 times. But the LCM is a product of all these 3 numbers. The LCM is 3 times 15 times 6. 3 times 5 is 15, times 6 is 90. Okay, so the first multiple, the smallest multiple that 15 and 18 share is 90. Tim had blah 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 2 and 3 gallons of milk. He's pouring into 1/7 gallons containers. How many full 1/7 containers will he have? Well, it's a division problem. 2 into thirds divided by 1/7. So how many times can 1/7 fit into 1 2/3? So one way of doing this, you have several ways. You can draw a picture, but I don't think you will. Well, let's change this to a mixed number, an improper fraction. 3 times 2 is 6, plus 2 is 8. 8 over 3 divided by 1/7. So the way we did it, we found a common denominator. The common denominator is 21. How does 3 become 21? Times 7. So 8 times 7 is 56. I multiply this top the same. And 7 times 3 is 21, so times 3. We can cross these out, right? And 56 divided by 3. And we can change it. We have to change this in order to figure out how many full containers we have. 3 goes to 56. How many times? Well, let's divide. Goes once, 3, 26. 3 goes to 26 18 times. 24. You're going to have some left over. So the final answer, so actually I should put a 2, is 18 full containers and 2/3 of another. But the answer said how many full ones. So 18 full ones and 2/3 of a container will be left over, of a gallon will be left over. Blah blah. Pay $8.20 for 18 stamps. How much would it cost Sam to buy 30 stamps? So this is a unit rate problem, or you can use unit rate. I'm sorry. So $8.28 for 18 stamps, and I'm going to use my unit rate to help me out. So I'm going to find out what 1 stamp is. So divide by 18, and that gives me the cost of 1 stamp. And 828 divided by, what are we dividing by? 828 divided by 18 is going to give me 46 cents per stamp. So each stamp is 46 cents. Now I can use this unit rate to help me out with 30 stamps. And again, very easy to find a relationship, times 30, and then times 30 on top. And the total, let me write times 30, it's going to cost me $13.80, or 13.8. If you just wrote it, that's also fine. What value of x would make this equation true? So equation is coming up, all right, after our current topic. And we have to find a value for this that will make this true. What can I add to 8.63 to make to equal 11.001? So one way of doing it is to use inverse operations, right? We can use fact families, and we can subtract 11.001 minus 8.63. Remember, you line up the decimals. I put a 0 here as a placeover, and I'll subtract. 1 minus 0 is 1. I can't subtract, so I need some borrowing here. So that becomes a 0. This becomes 11, which will become a 10. That becomes a 10, which becomes a 9, and that I can stop. 7, 3, 2. Final answer. value of x that will make this equation 2 is going to be 2.371. If I add that to 8.63, it will equal 11.0001. Did I say one too many zeros? Which two expressions are equivalent for any value of y? Well, if I substitute 1 over here, okay, so if I made y equals 1, over here I would get 6 times y, which is 6 times 1, which is 6, plus 6, which would be 12. So I get 12 over here. If I put a 1 over here, I get 3 times 3, which is 3 times 1, sorry, which is 3, plus 3, which is 6, times 3, right? Times the number outside, which is going to give me 18. So this is not going to be the same. So this and this are not the same. What if I make this a 1? Instead of a y, I change it to 1. So 9 times 1 is 9, plus 6 is 15. So this is going to be 15. What about over here? If I make that y a 1, it would be 3 times 1, plus 3, which is 6, times 3 is 15. Oh, look at that. This is the same. Just to continue this, what if we made this y a 1? So I'm going to put a 1 here. So it would be 12 plus 9 times 1. So 9 times 1 is 9, plus 12 is 21. So this whole thing would be 21. If I put a 1 here instead of the y, I get 1 plus 3, which is 4. 4 times 9 is 36. And these are definitely not equal. So far, B is my answer. And the last one, if I make that a 1, y a 1, it would be 9 times 1, which is 9, plus 27 is 36. If I made that a 1, 1, right? The y a 1, I get 1 plus 3, which is 4, and 4 plus 9 is 36. Ooh. This is also the same. So final answer for this, A and B ends up being the same. Okay. Another way of doing this is through the distributive property. So 3y plus 3. And over here you get 9y plus 6. If I do the distributive property, I get 3 times 3y, which is 9y, plus 3 times 3 is 27. 3 times 3 is 9. Uh-oh, so I made some mistake here. 9 plus 6 is 6. 3 plus 3 is 6. Plus 3 is 18. So this is not equal. Sorry. So, because this is 9y plus y, 9y plus 9, and this is 9y plus 6, so B is completely wrong. B is not equal to each other. Okay, and I'll work that out here. 3y plus 3, is this equal to 9y plus 6? If I substitute, I get 3 times 1 plus 3. So order of operation tells me I do 3 times 1, which is 3, plus 3 is 6, right? And 3 times 6 is 18. Let me put a 1 over here. I get 9 times 1 plus 6. 9 times 1 is 9, plus 6 is 15. And you can tell that they're definitely not equal. So B doesn't work. So the only right answer is D. 28. 28 students in 601 like vanilla. 12 students like chocolate ice cream. What percent of class likes vanilla ice cream? Okay, so first of all, let me set up the percent proportion with something out of 100. I know that in this class there's 28 plus 12 students. There's a total of 40 students. And what do we want to know? How many like vanilla ice cream? Well, the number of people who like vanilla ice cream is 28. So now I got to find out what percent that equal to. Let's divide this by 4. 28 divided by 4 is 7. 40 divided by 4 is 10. Now is there, so I'm going to take this ratio out and use a new one. Relationship times 10 times 10. That gives us 70. So 70% of the class like vanilla ice cream. Identify the coordinates and the quadrants for each letter. Okay, so hopefully you can see this. So we got A, B, C, D, E. A is negative 4 and 2, and it's in quadrant 2. B is 4 and 1, is in quadrant 1. C is 2 over and 0, so that is on the x-axis. D is 0 and negative 2, so that's on the y-axis. And E is 3 over, negative 3 over, and how much down? Negative 4 down. And that's on quadrant 3. Okay. Keith wants to plot negative 18 and negative 9 on the number line. Which statement is true? So why don't we go ahead and do that? That was a number line, and we don't need the pause, so I'm going to make that's 0, that's negative 1. And somewhere over here will be negative 9, right? Negative 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12, and negative 18 would be here. And here are two numbers, negative 18 and negative 9. What can we say about these two numbers? Remember what I said in class, the number to the right is always the bigger one. So who's the bigger one? This guy's the bigger number, because he's to the right on the number line. Okay? The more right you are, the bigger you are. So between these two, negative 9 is the bigger number. So Keith should plot negative 8 to the left of negative 9 because negative 18 is less than negative 9. That's true, right? Negative 18 is to the left of negative 9. Keith should plot negative 18 to the left of negative 9 because negative 18 is greater than negative 9, but that's not true. It's not greater. Keith should plot negative 9 to the left of negative 18, so negative 9 you're saying should be around here. No, that's not true. Keith should plot negative 9 to the left of negative 18. Again, it's not. Negative 9 is to the right of negative 18 because negative 9 is greater than negative 18. So although this is true, this is not true. Negative 9 is to the right of negative 18. So the only right answer is A. And, oops, what's going on? Is this a final answer? No. Oh, one more. Find the value of the expression. Yikes. We've got a lot of things going on here, and the first thing I would do is change this fraction to a decimal. 3/5 as a decimal is 0.6. 1/5 over here on the right is the same thing as 0.2. So I'm going to change things around. So 24.6, that's how I would write it, plus 4 to the third, times, in parentheses, 8.2 minus 2. And I'm going to change that to this. Oh, I don't like doing that, but just not to confuse things. So now I can do this. Order of operations. This I don't touch yet right now. 4 to the third, I can actually do it. 4 times 4, 16 times 4, 64. It's not going to change anything. It's not affecting. So that's going to be multiplying this subtraction sign. 8.2 minus 2 is 6.2. So order of operation tells me that I still don't touch the 24.6, but instead I have to multiply 64 times 6.2. No decimal places here, and one decimal place over here. So it tells me my answer should have one decimal place. So let's multiply. 2 and 4 is 8. 2 and 6 is 12. 0. 6 and 4 is 24. Carry 2. It's 36, 38. 8, 6, 9, 3. 396.8. Now I can add these two numbers, and that's not that difficult. So 396.8, make sure you line up your decimals. And it gets 24.6. 8 plus 6 is 14, carry the 1. 11, carry 1 again, 10, 12, and carry 1 against 4. So final answer, 421.4. That was a very short spiral, but we're done.